Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. In the previous tutorial we saw a look at ICMP redirection, and RFC 1122 states that the host should not send ICMP redirects, and however, just as the default gateways follow a set of guidelines as to whether they will send redirects or host also have a built-in specific set of guidelines of protections to prevent inadvertent additions to the routing. So I'll now teach you about the following checks that are typically performed at the host. Not all of them which are listed at RFC 1122 before adding a redirect route to the routing table. So the first point would be the new router must be reachable through a directly connected network. So if this router is connected through some other router, that some other computer, and it finally goes and reaches back to A, it won't work because it should be connected directly to the computer A, else it will not. The new router must be from the existing router for the destination in a question. So to simplify it, let's assume that router A is our main router, and this is a remote computer and this is our original computer. If I send a packet to that remote computer, and that sends a packet to the router will not be able to redirect it back to A. The reason being that this a specific computer, that is let's say a remote computer, it only accepts connections and data from A, whereas it only sends out packets to this specific router. It will not go ahead and accept anything back to A. So in order for the router to go ahead and connect back to A, it should be connected directly, not remotely. The third point would be the new route cannot specify the host as the next hop address. So let's consider something as, let's say for example, A has directed a packet to the router 1, and 1 cannot go ahead and redirect the packet to B through A or through the router. Means no, it can do through the router, but it cannot go ahead and send it to the same host to connect it back to B, because B will not be able to then recognize whether it was sent by A or 1, and it will be again in the loop as to from where it was sent in total. So that it should be connected either such as A, 1, 2 and B, or A, 1, A, end, and a new packet should be sent to the router 2. And yeah, that's how it will work. And the fourth point would be the redirect route must not point to an address on the local subnet. And the last point would be the host must be configured to accept redirects, because if A is not configured to accept redirects, and if the one goes ahead and passes the redirect, A will think of something like something is trying to pass the data along through A, and again it will go ahead and redirect it back to B, and again the loop will start and nothing will happen again. So in practice, some operating systems perform more security checks than others when adding redirect routes. So Windows is good in redirecting, but I would not say that it is very awesome or something like that. Even Ubuntu is good at that, but the best one feature which I would like to tell you would be from the Fedora and the Red Hat, because they are very much awesome in going ahead and configuring redirects, because they are made for that specific purpose, for being used by system administrator to know where each hop is connected, where each host is there, and where each route is there, which router is going ahead and redirecting all the parts, and they need to make sure that one is not redirecting the part back to some third party over here, which is a malicious attacker again. So now let's talk about the raw data. So the ICMP redirect error message is consistent with the format of all other ICMP error messages. So this is a breakdown of what the ICMP redirect packets look like. This will not give you much of an idea as to how exactly it should be, but this is how it will look like. The redirect message contains an ICMP type of 5 and a code between 0 and 3, that is from over here, 0 and from 3, that is where the code lies in between. The next comes the checksum and the IP address of the next hop router that should be used. Finally, the IP header and the first 8 bytes of the offending packets are included as a part of the ICMP data, and by offending packets I mean the packets that were redirected back to A and not the original packet, because once the packet is sent back to A, so I'll just go ahead and show it out to you. So once the packet is sent out from A, that is not the offending packets, but when it is sent out from 1 back to A, they are the offending packets. And this code field will allow the following types of redirect messages to be sent. So this is how it looks like. Notice that there's no place in the packet to delineate or a network mask. In practice, only codes 1 and 3 are usable. I'll just go back to the previous one. Only packets 1 and 3, only codes 1 and 3 are usable because a host cannot accurately guess the network mask in which the destination fails. Network redirects were designed in the days of classful routing when masks were implied, but very few networks are still deployed this way today. Based on the information purpose so far presented, it would seem that ICMP redirects serve quite a useful purpose. In fact, they do. Yet there are several reasons to steer clear from redirects, all of them relating to network performance, consistency, reliability, and security. And as you can see, 0 is the redirect datagram from the network, redirect datagrams from the host, that is 1, 0, 1, 2, and 3. The second one is the redirect datagram for type of service and network, and the third one is the redirect datagrams for the type of service and the host. So networks that qualify for ICMP redirects are inefficient. This inefficiency stems for several reasons. Firstly, packets that enter and exit the same interface and IP network towards their final destination are taking a suboptimal routing path. These packets should be forwarded through a different gateway in order to reduce the number of routing hops and in turn decrease latency and increase network throughput. Packets that enter and exit the same interface of the router are they are effectively doubling the load on that link. Secondly, as we noted earlier, ICMP redirects are not only host based because it is not possible for a host to guess for which networks a packet is being suboptimally routed to. So just consider this following program over here. Once again, host A would like to send a packet to B. The routing table on host A consists of only one default gateway and no other static rules. And this is the routing table from output from host A, that is a FreeBSD 4.6 system. And if you don't know what FreeBSD is, I'll just go ahead and show it out to you. It is mostly used for creating a firewall, and it has its own brother known as OpenBSD. I'll just go ahead and show it out to you, the operating system. So as you can see, here are the latest releases. You can just go ahead and click on that link and download all the parts that you need. And FreeBSD is an advanced computer operating system used to power modern servers, desktop, and embedded platforms. And this is quite a good and secure operating system, I can say that. And yes, you are right, you heard it right, it's an operating system, and it is not like the Linux or Unix that you would use. I'll just go ahead and show out an image to you as to how it looks like. Yeah, this is how it looks like, and yes, this is how it looks like in actuality. Just ignore this part. So this is how it looks like in actuality. You have Wine over here that can go ahead and run Wine programs. You have the pig, the snort, the buffalo that can go ahead and run multiple programs out there, even the Mac programs. And finally, you have Mozilla to safely go ahead and browse or go through whichever things that you need. And it's mostly used to go ahead and create, you can say as, let's say, for example, to go ahead and secure or create a firewall so that everything that comes in and goes out will be seen by FreeBSD, and it will keep logs for you to go ahead and understand how exactly or who exactly went through the records and how it will work exactly. Go ahead and start. Okay, so coming back to our tutorial, I'll just go ahead and show you one more thing. To see if host B is alive, host A sends two ICMP echo requests to host B as follows. And notice that host, as you can see over here, when you go ahead and ping it, notice that host A did receive an echo reply from host B. As you can see over here, packets were being sent out and it redirected host and was sent out back to A as well. So, but it also received, notice that A did receive an echo reply from host B, but it also received something it may not have bargained for, that is, one ICMP redirect for every packet destined to host B. This would have continued indefinitely until host A cancelled its ping, as we have done above. As you can see, I have gone ahead and cancelled the request, else it will still continue, and this arrow C, upper arrow C, means that I have gone ahead and cancelled that. So, even though host A received an ICMP redirect for every packet, you may think that why did not it take a new path right away? If we examine the routing table on host A once again, you notice that a host-based route was indeed installed for the IP address 10.0.1.32. I'll just go ahead and go back to my previous. So this one, it was already configured to go ahead and route it back to A, but it did not go ahead and actually redirect anything. So it would appear as if the ping program does not re-evaluate the routing table during runtime. The reason for this is explained quite elegantly by a guy named as Richard Stevens, who points out that this happens because there is no control input function for the raw IP protocol. It's only there for UDP and TCP. Since ICMP lies just above the IP layer, the redirects appear to be ignored. Thus, changes in the routing table are not taken into account until we stop and rerun the program, like I have done so over here. Okay, so that's how it looks like in reality, and we need to go ahead and cancel that one again, but I won't be explaining this to you in this tutorial. In the next tutorial, I'll be continuing the same part, so make sure that you have watched this tutorial first and only then you go on to the next tutorial, guys.